Okay, right. We are starting right now, and the time is exactly 14. It's exactly 14:22, and we shall see. We need to cover 2 hours of our discussion, so we record our time on the screen. Right. To start with, we are looking at the following shapes. This is a worksheet, and therefore we're going to work through the questions together. So we are actually asked here to learn how to determine the perimeter of a figure. Given this figure, how do we find the perimeter of this figure? How do we find the perimeter of this figure? Right, to find the perimeter of this figure, the answer is, right, so we are first learning and then I'm going to give you a couple of exercises. Right, the perimeter is defined as the sum of the lengths of the sides of the triangle, of the shape. Right, so we have 6 centimeters. We add it to 5, so we have 6, then we have 5 centimeters, and then we have 3 centimeters, and then we have 8 centimeters, and then we have 7 centimeters, and then we have 4 centimeters. So the perimeter therefore is, right, so if you add all these numbers, what we get is actually 33 centimeters, and this is the perimeter. So what is the perimeter of a shape? Right, the perimeter of a shape is the sum of the length of the sides of the shape. So we look at the next question. To do the next question, I'm giving you 2 minutes because it's out of 2 marks. Right, so now, are you able to see the screen?
Yes.
Okay, good.
Clearly.
Can you be able to see question 1.2 that I've just encircled?
Yes, clearly.
Right, please, I'm giving you 2 minutes to try it. 2 minutes. Work out the perimeter of this shape. So what is the perimeter of this shape? Work it out. And I'm giving you like 2 minutes. And you give me the answer when you're done.
Okay.
You need to have your scribbler, in which you write the things I'm
Yeah.
going to order you to write. Okay.
So the answer 20.
What do you think the answer is?
20.
Okay, let's check the answer. Yes, congratulations. Here the perimeter is actually the same as 6. 6 centimeters, right, plus 4 centimeters, plus 3 centimeters, plus 3 centimeters, plus 4 centimeters. So the perimeter, if you add all these, you get 20. Well done. The next one is actually the perimeter of the following irregular shape. So this one here, it becomes the perimeter of the irregular shape. So how to find this one is very easy. So at this point, we are able to get the perimeter of this shape. And what is the perimeter? It's actually the same as the sum of these lengths. So you have 5 centimeters, 6 centimeters, 4 centimeters, 5, 6. So we have 5, 6, 4. Then we go for the 3 centimeters, and then we include, so we've included the 3, we put the 2 centimeters. So now it means, therefore, here, the perimeter is the sum of the lengths. What is the sum of the lengths in 1.3? 20 as well. 20 centimeters. Okay. So now we're going to do 1.4. So in 1.4, start with the polygon and answer the questions. Start with the polygon and answer the questions. Determine the value of x and the length of the unknown side. Right. I'm giving you 2 minutes to try this question, then we shall do corrections together. 2 minutes to try this question. I'm giving you 2 minutes to determine the value of x in this question. Determine the value of x in this question.
Okay, the answer is 3.
The answer is 3. Well done. Okay, so right, because we're able to see in 1.4.1, this one here, that the answer is the same as the following. It is 3. I agree with you, and we shall just do it together. So we are practicing because these are worksheets, and therefore I need obviously your participation so that I can be sure that you're learning as you go along, because now learning is inculcated. We inculcate learning. So at this point, we're able to realize that the variable x is actually the 7 here,
Minus
7 centimeters, minus this 4. If you say 7 minus the 4 is equal to 3 centimeters. So x is 3 centimeters. The next thing is 1.4.2. Calculate the perimeter of the shape, the perimeter of the polygon. Right, so the perimeter is very straightforward. So we do the perimeter now. We can just do that one together. Right, so the perimeter would be therefore the 7 centimeters plus, you do 7, then 2 centimeters plus another 2 centimeters plus 3 centimeters plus 6 centimeters plus 4 centimeters plus 13 centimeters. Right, so you take all these and you add them up. And if you do add these up, what do you get in the end of these? Right, so what you get at the end is that what you have is the sum of all these, and the sum of all these in 1.4.2 should be 37. Should be 37 centimeters. Okay, we're good. Next question. The next question is about more shapes, but we're looking at a question 2 in a series of our worksheets where we are practicing more mathematics and more math. Right, into question 2, we want to determine the perimeter of a square if the length of one of its sides is 3 centimeters. Right, so what is the perimeter of the square there in 2.1? So in 2.1, then you're going to find the perimeter. The perimeter is 4 into 3 centimeters. Four into 3. Because this length of one of the sides is 3 centimeters. So now in a square, you multiply by 4 because the square has 4 sides. So 4 times 3 gives us 12 centimeters. Okay, so we have done that one together. So we have done 2.1 together. I'm giving you 2.2 right now as an exercise. A square has a perimeter of 64. What is the length of each side of the square? I'm giving you 2 minutes. Try that one, please.
Hmm.
Let me know when you're done.
Okay. Is it 16?
Well done. It is exactly 16 because now, if you want to find, because a square has the perimeter of 64, it means that the perimeter P is equal to 64. But obviously, you're dealing with a square, so the perimeter is 4 times the length of each side, and you call each side x, which is 64. And then now you proceed to this point where you need to get x. So to get x, what you do is you take the 4x, which is 64, okay? You divide on the left by 4, you divide on the right by 4, and then now you get x is the same as if you divide 64 by 4, you get exactly 16 units, okay? So you have 16 centimeters. Okay, so well done there to note the fact that the actual length of each side of the square is actually 16 centimeters. So obviously here we are done with this one. Next question.
Okay.
Look at the 2D picture of Randy's pool and answer the questions. Right, we are looking at the 2D picture. What is a 2D picture? What does it mean to say a picture is 2D?
It's flat.
It's flat. Thank you. But now we in mathematics, we mean it is two-dimensional. It means it is two-dimensional. The D stands for dimensional. So in other words, we are speaking about a two-dimensional picture of Randy's pool and answer the questions. So we are looking at Randy's pool, and here is Randy's pool, and we can see it. Okay, convert right now. Okay, want to convert, for instance, 300 millimeters to centimeters. Have you ever learned how to convert millimeters to centimeters?
Yes, I do.
Okay, okay, try 2.3.1, and then we're gonna do corrections together, please.
Is it 30 centimeters?
It's exactly 30 centimeters. So in other words, when you have 300 millimeters, you divide that by 10. And if you divide it by 10, it becomes 30 centimeters. So to convert from millimeters to centimeters, you divide by what? By 10. Okay. Hence, determine the perimeter of the rectangle. So the perimeter of the rectangle, this one is going to become what? Okay. So now in 2.3.2, we continue as follows. So the perimeter of the rectangle here, this one is going to become like 30 centimeters. Obviously, these are opposite and therefore equal to each other. 30 centimeters, this is 13, and this becomes 13 centimeters. What is the perimeter? P. So the perimeter here is the same as 2 into the sum of the sides. So it's 2 into 13 plus 30. 13 plus 30, which is 2 into 43. What is 2 into 43? 2 into 43. 2 into 43 is what? Is 86. Next question is 2.3.3. 2.3.3. Randy wants to put a fence around the pool. It costs 20 Rand for 21.5 centimeters of fencing. You want to put some fence around the pool so that children do not drown in the pool, so that animals do not drown in the pool. But he must buy the fence. To buy the fence, he realizes that it costs 20 Rand for 21.5 centimeters of fencing. Determine how much Rand it will cost to fence the pool. I'm giving you 2 minutes to try this one, then we shall do corrections together.
Okay.
Yeah.
So does he have to pay 80 Rand for 86 centimeters of
That's
fencing?
correct, because the cost in Rand. The cost in Rand is given by the cost in Rand. Right, you need to learn a couple of things, obviously. You need to learn that you have 20 Rand, but now to get the cost in Rand, you need to look at the total amount of fencing that this guy needs to have. So the perimeter is actually 86. And therefore you multiply that by 20 Rand. 20 Rand for 20 Rand for 21.5 centimeters. And therefore you get the answer. If you do the calculation, you get exactly 80 Rand. So in other words, you have to determine how much in Rand it will cost to fence the pool. It will cost exactly 20 Rand. It will cost exactly 80 Rand. 80 Rand. Okay, next question. Determine the area of a square if the length of one of its sides is 5 centimeters. Okay. So here the area of a square is always side times side, but the length of one of its sides is 5, right? So you have 5 centimeters. You multiply by 5 centimeters. 5 by 5 is what?
25.
It's exactly 25. So you have 25 square meters. But as we continue, you must be able to work out the area of the rectangle. So we have a rectangle here. What is the area of this rectangle? Okay, I'm giving you 1 minute. Please try this one, 3.2, and give me the answer. You done?
No, not yet.
Okay, that's
Where's
fine.
the-
All right, I know you're gonna finish. So to work out the area of the rectangle, we need to remember that the area is length by what? It's length by breadth of the rectangle. The length is 12 centimeters multiplied by 2 centimeters. So in 3.2 then is 12 by 2. What is 12 by 2? Is 24. So it's 24 square centimeters. Okay, so that is the answer to the area of the rectangle we had to work out. Next question. Here we have the area of a triangle. The area, calculate. So we need to do a calculation. Calculate the area of the triangle.
Okay.
Right, so to find the area of the triangle, we can compute with ease because the triangle, what is the area of the triangle? So area here in 3.3 is the same as what? Area is actually half base times height. 4, which means the area is half the base, which is 6 centimeters. And the height is what? Is 7 centimeters. So you have the area. What is half of 6?
3.
3 times 7. 21.
21.
Good. So it's 21 square. 21 square centimeters. And that is the area of the triangle. Okay, so the area of a triangle, to find the area of a triangle, use the formula. You need to recognize the base. And you need to be able to recognize the height. Right, in which case then you put the two together. Next question. Study the complex polygon. Study the complex polygon and answer the questions. Convert meters to centimeters. Okay,
Okay.
let's start. Like if you have this 0.06 meters, this one here, try to convert it to centimeters and then we shall do corrections. Now, so how do you convert meters to centimeters?
Um,
Let me know when you're done.
is this 6 centimeters?
That's a good question. Is it 6 meters? Yes, it is. Right. The reason for that, obviously, is because you need to multiply by. So you need to learn that 1 meter is actually 100 centimeters. Right? The meter cancels the meter. So 1 meter is 100 centimeters. But the meter cancels the meter. So you multiply by 100. To convert from meters to centimeters, what you do? You multiply by 100. If you multiply by 100, therefore the result is exactly 6 centimeters. Let's find the area of this polygon. I'm giving you 2 minutes to find the area, then we shall do corrections. So this one is exactly 6 centimeters. Okay, please do 3.4.2 and let me know when you're done. Please do that and let me know when you're done.
So is the total no,
Please come again. Okay, what are we supposed to do? We need to calculate the area, isn't it?
yes.
All right. So the question is, what is the area of this? Okay, this is called a complex polygon. Complex polygon. So we're asking the question, what is the area of this complex polygon? What is the area of this complex polygon? I'm giving you 2 minutes to find the area, then we shall do corrections together. Because these are worksheets, so I want us to work together from time to time. So I give you a chance to work out the question and I quickly verify the correctness of the answer. I quickly rectify the correctness of the answer. Let me know when you're done, please.
I'm struggling a bit.
Is it too easy? All right,
No.
all right. Okay, let me give you like a minute, 1 more minute, and then we shall do corrections because I want you to learn how to stretch your mind. Okay, it's not a question of you getting 100% always. The reason why we go to school is not because we are perfect, but it's because we want to be made perfect. So when you come to the discussions here, we want to train you so that you become perfect, you know?
Yeah.
Yes. When you're done, please let me know that, okay, I'm done. Please let me know.
Okay.
Right, so here's the answer to that because I can see that you're thinking and it's okay to think. It's all right to think. So in 3.4.2, you want to find the area of the shape. Right, so this shape is formed by two things. So you have the area of a triangle first. So in other words, you have the area of the triangle, area of the triangle. What is the area of the triangle? The area of the triangle is half base by height. What is the base? The base is 4. The height, 6. So the height is exactly 12. Centimeters. The area is 12, excuse, of the triangle. Then now you also have, so this one is a triangle. And then this one is a rectangle. We're asking with the question, what is the area of the rectangle? The area of the rectangle. So the area of the rectangle is length by breadth. What is the length? Is the longest side? So this one you would say is the length. So the length is 8 centimeters times the breadth. What is the breadth? So it's the length by the breadth. The breadth is this one here. This is the breadth. The breadth is 6. What is 8 by 6? Exactly 48. 48. So this is square. Centimeters, and this is 48 square. So centimeters, the total area. The total area is exactly 12 plus 48. What is 12 plus 48? It's 60.
Mm.
So to find the area of this complex, we call it a complex polygon because it's a polygon that combines shapes. So you need to first deal with the triangle, then the rectangle, and then you get the total area. So you add the answer from the area of the triangle, and then you add to the area of the rectangle, and you get the answer. And the final answer is 60 square centimeters. Next question. Okay, question 4.1. What's the answer? Calculate the height of the triangle if the base is 8 centimeters and the area is 36. I'm giving you 2 minutes to try 4.1 and then you do the corrections. Let me know when you're done, please. You're done.
No.
Okay. Okay, I'm giving you 1 more minute.
No. No. Kind of struggling here.
All right, that's fine, because that's why you're here. That's why, because here we're here to train you so that you become a warrior in mathematics, that you become a mathematician. To calculate the height of the triangle, if the base length is 8. So base length is 8, it means the base is 8 centimeters. And the area is this. So it means the area is 36. So which means therefore the area is half base by height. So the area, you put the area is 36. Half the base. The base is what? You substitute, the base is exactly 8. And then you can leave out the units. The height is what we want because they want us to calculate the height. So if they say calculate the height, it means the height is actually question mark. So the height equals a question mark. So you come here and say 36. What is half of 8?
4.
H. Right. So you take the 4H and you have the 36. So you divide by 4 and you divide by whatever I've done on the left, it must be done on the right. So this is the height. So what is 36 divided by 4? It's exactly 9 centimeters. So the height they want is this one here. The height is exactly 9 centimeters. It is 9 centimeters. Okay, so just note that you're dealing with the centimeters, so it's exactly 9 centimeters. Okay, because we're writing the answer in centimeters because the base length is in centimeters and the area is in square centimeters. The base length is in square centimeters. Okay, so we continue. Right, the next question is about Sarah. Sarah has a rectangular garden patch. So this is a garden patch and it's growing some flowers here. It's growing things here in the garden. Work out the perimeter of Sarah's garden in meters. What is the garden in meters? So you need to convert this one to meters. To convert this one, the centimeters to meters, you need to remember that 1 meter is equal to 100 centimeters. So you divide by, because this centimeter cancels this one, so you divide by 100. 100 goes how many times into 300? It goes 3 times. So 3 times 1, you have 3 meters. Then now you have this one, this 800. You need to convert the 800 to meters, right?
Yes.
You need to know that 1 meter is equal to 100 centimeters. So the centimeters cancel and the 100 goes here 8 times. So now you have 8 by 1, which is 8 meters. So what is the area? So the area is actually length by breadth. What is the length? The length is 8 meters. What is the breadth? The breadth is 3 meters. What is 8 times 3? 8 times 3 is actually 24 square meters. So the area is actually 24 square meters. Okay, so we continue right now. We continue right now. If you look at 4.2.1, work out the perimeter of Sarah's garden patch in meters. Work out the perimeter of Sarah's garden patch in meters. Right, so we've worked out the area in meters. Then let's look at 4.2.2. Okay. Anyway, they wanted the perimeter, not the area. So they wanted the perimeter. So the perimeter can be found similarly. Just note that. So we add everything and multiply by 2. So obviously at this point, we realize, therefore, that we can be in a position to do this with ease and get the answer. So at this point, they want the perimeter. So you say perimeter is equal to 2 into the length plus the breadth. What is the length? It's 8 meters.
The,
What is the breadth? 3.
3.
Right. So what is the answer? Right. So at this point, you need to get the answer. So the answer is going to be 22. Because 8 plus 3 is 11 times 2, 22. 22 square, rather 22 meters only. 22 meters only, because you're just adding everything up. Just adding everything up. So we're done. Right, let's look at 4.2.2. The garden will be covered with shade. It will be covered with shade cloth. Okay, because now sometimes the sun is very hot, like today. It feels a bit hot in many parts of South Africa. We are fast approaching the summer season from spring, and the days are getting hotter. So we're approaching much warmer days in the summer, so or in South Africa. And therefore the garden will be covered with a shade garden so that the sun does not scorch the vegetables and the crops. Right, work out how many square meters of shade cloth Sarah will need. Work out how shade cloth, how many meters of shade cloth Sarah will need. Right, so let me give you 2 minutes to try 4.2.2. 2 minutes. And you let me know when you're done.
Okay.
Yeah. Okay, so let me know when you're done.
Okay.
Okay.
So is it 12 meters squared?
You're just there because we are dealing with the how many square meters, so we're gonna find the area. So the area of this one is length by the breadth. What is the longest side? It is 8 meters. The breadth or the width of this is 3 meters. What is 8 times 3? It is exactly 24 square meters. So in other words, we're dealing with 24 square meters of area, because they said work out how many square meters of shade cloth must be what will be needed, right? So you have exactly that one. You have exactly that one. So any question there? Right,
No.
we continue. We solve more and more problems. Let's look at some serious stuff a little bit. All right, we're doing exercises, and therefore it's very important that you understand these exercises very much. So now we are fast approaching a set of problems there. So we continue. Let's do this one. So there are some other problems that we need to do, like this one. So this one is very easy. We're gonna just run through these problems and practice together as we prepare for the final exam and as we learn mathematics together. Okay, first things first. These ones are actually purely multiple choice. Write down the letter of the correct answer next to the question number. What is the name of the line segment that divides a circle into 2 equal parts? Is the answer A or B or C or D or neither of those? In other words, is the line called a radius? Is it called the circumference? Is it called a diameter? Is it called an arc? There is one answer to this question. Right, your thoughts, please, on this one here. Have you ever seen something like this before?
Yeah, we did this last term.
Okay.
I think it's neither because radius is from the center point to the circles. So I think it's diameter because it's from yeah. I think it's diameter because it's from end to end of the circle.
Yes. Yeah, the name of the line segment that divides a circle into 2 parts is called the diameter, because if you have a circle like this, a diameter runs through the center of the circle. And now if it runs through the center, it divides the circle into 2 equal parts, and this line is called a diameter. is called the diameter. Right, so you have the questions to practice, or let's get cracking here. Let's get cracking here. Let's get cracking. Right, so the next one is, if 5 meters is converted to centimeters, the answer is, okay, so we're
5.
converting 5 meters to centimeters. So to convert that one, you take the 5 meters, you multiply by, if you convert it to centimeters, you need to remember that 1 meter is what? Is 100 centimeters. The meter cancels the meter, and therefore you have 5 by 100, which is 500. So what is the answer to 1.2?
500.
500, and therefore the option is D. In 1.3, we call the instrument that we use to measure angles. What do we call that instrument that we use to measure angles? In 1.3, there's an instrument we use to measure angles. Is it called a compass? Is it called a retractor? Is it called a protractor? Is it called a peppers? What do you think? Have you ever seen the instrument that is used to measure angles?
Yeah, but I can't remember it.
All right, it's called a protractor. Right, so in other words, there a protractor is like this. And then now it has something here, then you have like the sun. Then here you have 0 degrees, and then here you have 10 degrees, and then here you have 20 degrees, and then here you have 90 degrees, and then here you have 180 degrees. It's like a ruler, you know, but it's
Yeah.
curved like this. That is called a protractor. 1.4. An angle less than 60 degrees is called a angle. There are those angles that are less than 60 degrees. What do you call an angle that is less than 60 degrees? It's called a straight line angle, an acute angle, an obtuse angle, a reflex angle. What do you think?
An acute angle.
It's called an acute angle. So now, obviously, an acute angle is an angle like this. So it's actually less than 60 degrees, and therefore it's called an acute angle. Okay, in 1.5, we need to practice things like your equilateral triangles. An equilateral triangle has sides. Okay, has 3 equal sides, has 2 equal sides, has 1 equal side, has no equal sides. What do you think 1.5 is actually?
It
I won't
is
involve you because it's a worksheet. You'll forgive me because it's a worksheet. I want your mind to work. So please, you must forgive me.
it is. I think it has no equal sides.
Okay, that's fine because we're practicing. It is an equilateral. So the word equi means equal sides. Lateral means sides. So you could translate these to say equal sides triangle. And that means if a triangle like these, all of the sides are the same length, and it's called equilateral. So in 1.5, therefore, we understand that we have 3 equal sides. 1.6. 2 intersecting straight lines are said to be what? When the angle they form is equal to 90 degrees, parallel, perpendicular, point, parallelogram. 2 intersecting straight lines are said to what? When the angle they form is equal to 90 degrees. So what's the answer? What do you think the answer is here?
Perpendicular lines.
What do you think the answer is?
Yeah, I think it's perpendicular.
Yes, definitely. So in 1.3, 1.6, it is perpendicular. So in other words, you have 2 intersecting straight lines like this, and the angle, when the angle they form is 90 degrees, these are said to be perpendicular. Perpendicular. Let's look at 1.7. Each corner on the inside of a square is a what angle?
90-degree angle.
Right. Each corner on the inside of a square is how many degrees?
90.
Is 90 degrees. Well done. Congratulations. You have a square like this, and each corner is 90 degrees this way. Right. So each corner is exactly 90 degrees there. 90 degrees. Right. So if you look at 1.8, the sum of the angles of a triangle is what? 1.8. So is it 150? Is it 160? Is it 170? Or is it 180? What do you think? Are you able to see the question?
Yeah,
What do you think the answer is to 1.8?
I think it's 150.
But that's fine because we're practicing. But the answer is that it is 180 degrees. So the sum of the angles of a triangle, if you add all of them up, this one is angle A, this is B, and this is C. So if you have angle A plus angle B plus angle C, you get 180 degrees there. So you add all of them up, and the reason is that it is a law that the sum of angles of triangle, the sum of angles of triangle is 180 degrees. Next question, 1.9. If one cup can hold 250 milliliters, how many cups of cool drink can I get from a 1 liter bottle?
4 cups.
So in 1.9, what do you think the answer is?
I think it'd be 4 cups.
It will be 4 cups, exactly. Well done. So it will be 4 cups because we are dealing with 1 cup can hold 250 mils. How many cups of cool drink can I get in 1 liter? So obviously you understand that a 1 liter, right? So 1 liter will actually be the same as 1,000 milliliters. So you have 1,000 milliliters. So now at this point, you just divide everything by 250 milliliters to find the number that's required, which is exactly 4 cups. Which is 4 cups. So it's exactly 4 cups. If you divide 1,000 by 250, you get 4. 1.10. The area of a square is calculated by using the following formula. Which one? Area is side cubed. B. Area is side to the power 1. C. Area is side to the power 4. D. Area is side squared. Which one is it? What do you think?
I think it is area side cubed.
Okay, that's fine because you're practicing, but always remember that when you're dealing with the area of a square, it is the side squared because it is a square, so it is squared. Okay, right.
Okay.
So next question. Okay, I'm going to get back to these congruent shapes and composite shapes, but I want us to look at more serious things now. Because I'm trying to make sure that you become a very good student, but excellent student. Let's start with something more serious. Question 1. Question 1 will be multiple choice, and then we shall look at long questions. But first, we start with easier things, and we build to more complex. Write down the letter of the correct answer next to the question number. So if you look at 1.1, what is 2 in this? What do you think the answer is?
I think it is
1.1?
a
Please come again.
I think it is a coefficient.
Yes, most definitely. 2 is the coefficient because it's sitting next to the variable x, and therefore it's called a coefficient. Okay, right. The algebraic number sentence, which consists of constants and variables with no equal sign. Algebraic number sentence. with no equal sign. Is it a formulae? Is it an equation? Is it an expression? Is it an algebra? Your thoughts, please.
I think it is an expression.
Most definitely, it is an expression. Well done, because an expression has no equal sign, like 2x plus 7 is just an expression. Is an expression. Next question. So in 1.3 now, if x minus 5 is equal to minus 9, then the value of x is what?
14.
14. Let's check that one. Okay, 1.3. So in 1.3 now, we shall have x minus 5 equals minus 9. So you have minus 5, you add 5, you have minus 9, you add 5. So you add the 5, you add the opposite of the negative. So these cancel out and you have minus 4. So which means therefore in 1.3, the answer is B, minus 4. Minus 4. Okay, let's look at 1.4. What are the next two numbers? The next two numbers in this sentence. So here you have 11, 14, 17, 20, blah, blah, blah. What are the next two numbers? Are they A, 22, 25, B, 23, 26, C, 24, 27, D, 25, 28? Which ones? Which
I think
answer?
it is 23, 26.
Okay, well done, because you can see that here you increase by 3. Right, you just add 3, you add 3, so you get 23, and then you add, you get 26. 23, 26. 23, 26. So if you look at 1.4, the answer is B, 23, 26. Now let's look at 1.5. What do you think the answer is? Determine the value of x if that is the case in 1.5. What do you think the answer is? Is the answer 2, 4, 6, 8? Which one?
I think it is 8.
Okay, let's check together. So if you're dealing with that one in 1.5, so you have 32 over x is equal to 4. Right, so what you do, you cross multiply. If you cross multiply, it becomes 32 by 1 is equal to 4x. When you have 4x and 32, you divide the left by 4, the right by 4. X, 32 divided by 4 is actually what in 1.4? Right, in 1.5, excuse me.
It's 8.
1.5 and you're getting 8. So the answer is D, 8. Okay, if you look at 1.6, what do you think the answer is to 1.6? Is the answer 6, A or B, 8, C, 10, or D, 12? I'm giving you a minute to calculate that one. Please, what do you think the answer is? You're done.
Mm,
Okay, you add 65 and 36, you get 101. And the square root of this is approximately, so you just need to get the square root of that. So the square root of 101 is approximately 10.05. So the answer will be C. Next, the prime factorization of 120. What do you think that is? One 1.7? What do you think the answer is?
It is C.
Exactly C. Because you start with 120. And if you divide it by 2, you get 60. You divide 60 by 2, you get 30. You divide 30 by 2, you get 15. You divide 15 by 3, you get 5. You divide by 5, you get 1. Right. So you can see, therefore, that these are 1, 2, 3. So you have 3 2s and 3 and a 5. So the answer is that 1.7 is C. Okay, so let's continue. The next thing now is to look at more worksheets. Let's look at something different for this term. Let's look at something for this term. Okay, let's look at this one. Right, there are more questions we're going to be looking at, but obviously we're practicing to master the whole syllabus for grade 7 mathematics. These are still multiple choice, and then we shall look at long questions where we calculate. So we learn both multiple choice and the long questions. Write down the letter of the correct answer next to the correct number. Write down the letter of the correct answer next to the correct number. So in 1.1, the mode of a data set is the what? Is it the mean number? Is it the middle number? Is it the most frequent number? Is it the maximum number? So if you look at that one, what do you think the answer is? I'm giving you 1 minute to try that. It's just 1 mark.
Mm,
What do you think?
the most frequent number.
That's correct. Yes. So the mode is the mode of a data set is the most frequent number. Right. In 1.2, there's something we call a reflex angle. So a reflex angle is an angle that is what? That is greater than 180 but smaller than 360. That is greater than 90 but smaller than 180. That is greater than 60 but smaller than 90. That is greater than 30 but smaller than 60. Which one do you think is the answer? You have 1 minute.
I think it is A. Greater than 100, 180, but smaller than 360.
Right. So we're looking at that one there. Right. So we're dealing with the reflex angle, obviously in exactly 1.2, and you think the answer is greater than 180, but smaller than 360. That is a reflex angle there. Right. So that is a very interesting point. So you are certainly very correct. Right. So the reflex angle is actually greater than 180 but smaller than 360 degrees. So in other words, the reflex angle is an angle like this. Right. That is greater than 180 but smaller than 360. Right. So you measure the angle like here. And this angle is called a reflex. It's called a reflex angle. It is called a reflex angle. So this angle is measured in a counterclockwise direction, and it is an angle that is bigger than 180, but it is smaller than 360 degrees. Okay, because we have exactly that one. An angle of 360 degrees would be an angle like this, or if you measure it like this, so this angle will actually be a complete revolution, which is 360 degrees. Right, so let's look at the following diagram. It's very nice and decorated, 1.3. The diagram is an example of what? Okay, because you have that you have a dog, you have a hamster, you have a cat, you have fish, you have parrot. You have parrot. So what is the next thing that must be done there? Right. So what's the answer?
I think it's fish.
Okay, let's look.
Oh, I
In
didn't see
other
that.
words, this diagram is an example of a what? Is it is it a bar chart? This is it a histogram? This is it a double bar graph? Is it a pie chart? What do you think the answer is to this one here? 1 point something? 1.3.
A pie chart.
It is certainly a pie chart. Well done. The pie chart this. So this is actually a pie chart. It is certainly a pie chart. Next question. Now in 1.4, we're looking at some triangles. The triangle ABC is 2 times bigger than the triangle DF. What will the size of angle E? What will be the size of angle E after the reduction? Your answer. You have 1 minute. Think about it.
I think it is 60 degrees.
Let's look at it together. Okay, let's look at it together. 1.4. Right, so the triangle ABC is 2 times bigger than triangle DF. What is the size of the angle E after the reduction? Right, so obviously because this triangle is what? It's equilateral. So these sides are equal, it means the angles are also equal. So, but here also, these are also equal, this. Okay. And that's the answer. So in 1.4, 3. 60 degrees. The area of a square with sides 10 centimeters is equal to what? What's the answer?
I think it is 100 centimeters squared.
Okay, yes, that is that. So the area of a square, so in 1.5, you therefore realize that if you want to find the area of a square, it is a side times side, so which is 10 times 10. And 10 times 10 is what? Is 100 square centimeters. So the correct answer in 1.5 is actually letter A. 1.6. The transformation shown in the diagram is a what? Is it a reflection, translation, rotation, enlargement? What do you think? 1.6. We're doing 1.6.
Translation.
Okay. It is most certainly a translation because you can really see that here 1.6, a translation is a direct movement of the shape. So it was just moved across and therefore translated there. So it is most certainly a translation there. Okay, it is a translation, was just moved across there. Okay, let's look at 1.7. Johnny has a bag of marbles. Johnny has a bag of marbles. The bag contains 2 blue, 3 yellow, and 5 red marbles. What is the probability that he will pick a yellow marble from the bag? 1.7. 1.7.
It is 2
Okay,
over.
what do you think the probability in 1.7 is? I'm giving you 1 minute.
I think the probability is 2/10.
You think it's 2/10?
Yes.
Okay, let's check together. 1.7. So obviously Johnny has a bag of marbles. The bag contains 2 blue, 3 yellow, and 5 red. What is the probability that you will pick a yellow marble from the bag? So obviously you understand that there are 3 yellow marbles. So it's 3 out of the total number of all the marbles. So in other words, it's a 3 yellow out of 2 plus 3 plus 5. So what is the answer? Is 3 out of 10. So 1.7, the answer is 3 out of 10, which is C. So that is the probability. That is the probability. Next question. Right, the 3D shape is a what? Is it a square-based pyramid? Is it a triangular-based pyramid? Is it a triangular prism? Is it a rectangular prism? What do you call the shape? 1.8, your answer, please. We'll discuss the answer together.
I think it is a square-based pyramid.
Okay, let's look at 1.8. Congratulations. It's certainly there in 1.8, a square-based pyramid. It is a square-based pyramid because the bottom is more of a square. Bottom is more of a square, so it's square-based. Next, square-based because of the base like this. 1.9. The formula for the surface area of a rectangular prism is what in 1.9? The formula for the surface area of a rectangular prism is what in 1.9? Is it the surface area? Is it, which is length by breadth by height? Is it length by length by length? Is it 6 times the square of the length? Is it what is written in D? Which one? I'm giving you a minute to think about it, then you do corrections.
I think it is D.
Please come again.
D, surface area 2, that length times height
Yeah,
plus
that's
2.
correct, because we're looking at the formula for the surface area of a rectangular prism. So the surface area of a rectangular prism is what? So if you're dealing with this here, right, so is length by breadth by height. Right, so to find the surface area, you find the areas of all the surfaces. So it means it is 2 into length by height, 2 into, that is length by height, this one, then you do this one first. Then you do this one too, which is breadth by height. It's 2 because it's for this one and the other one there. So this one is for the top and bottom. Then you look at the yeah, it's for this one here and that one there. Then now you look at the top and bottom. And then now you have 2 into length by breadth. Right, so you have that. So 1.10. So the correct answer in 1.9 is D, we agree. The line that forms a circle is called what? It's called the diameter, the circumference, the radius, a sector. Which one? 1.10. You have a minute. What do you think?
Line that form the circle. I think it is the circumference.
Well done. So it is a circumference of a circle. In other words, if you have a circle like this, what you're dealing with here is called the circumference of the circle, which is the boundary of the circle. The boundary of the circle is certainly called the circumference of the circle. Right, now in question 2, we're looking at more circles and circle shapes. Right, so we're starting the diagram and answering the questions that follow. In 2.1.1, we're looking at the circle. Which parts of the circle are the line BC? What do you call line BC and line AD? What do you call line BC and line AD? Two marks. Let's start with BC. What do you call line BC?
Parallel, perpendicular.
Well, that's fine. Right, line BC is like this. Line BC. This is B and this is C. So BC is the diameter. Because it passes through the center so that this one is equal to this one. It's called a diameter. What about line AD? Line AD. What do you call line AD? This is A and that is D. There's a line that is like this, from the center to the circumference. What do you call that line?
The radius.
It's called the radius. Called the radius. So that is a radius. Right, because now we are dealing with the line from the center to the circumference of the circle. So this line, the specific name is called the radius of the circle. Right, so the couple of things we need to consider in 2.1.2. What type of triangle is triangle ABC? ABC. What do you call this triangle ABC? It has a special name.
Equilateral.
Please come again.
An equilateral.
All right, never mind. Okay, we have a triangle like this that has two sides equal. It is called isosceles.
Oh, isosceles.
Yeah, it is called an isosceles triangle. It's called an isosceles triangle because it has only a pair of adjacent sides equal. Okay, equilateral obviously means all equal. So this becomes equilateral, equal sides. The word lateral means equal sides. Next, what type of triangle is ACD? And what is its size? ACD. What type of triangle is ACD? ACD. 3.1.3. What type of triangle is ACD?
I think it is
Okay, when you're looking at the angle ACD, okay, they made a mistake here. They meant ADC. They meant ADC, but now they just typed ACD. Okay, what is ADC?
And
Okay,
I'm not sure. Une isosceles?
okay, that's fine. If you get angle ACD in ADC, is this angle there? ADC, what is this angle here? It is called a right angle because it's the type of angle. It is called a right angle, and the size is 90 degrees. And the size is 90 degrees. Okay, in 2.1.4, they're saying the triangles ABD, ABD and ADC similar or congruent? The triangles ABD and ACD, are they similar or congruent? Give a reason for your answer. What do you think, 2.1.4?
Similar.
They are similar. What? Okay, that's fine. I need to give a reason for your answer, 2.1.4. 2.1.4. Okay, so the two triangles are congruent. The two triangles are congruent. So in 2.1.4, the answer is they are congruent. They are congruent. They are congruent. In the right angle triangle ABC, the reason is that AB is equal to AC. Okay, they'll be marked equal to each other. Right angle triangle ABD, the hypotenuse BD is equal to the hypotenuse AC. So AC and AB are the same. They're equal to each other. And the corresponding side CD is in the second triangle ACD. So you have a couple of things here. So we have that AB is equal to that, but you also have that BD is equal to CD, but you also have that if you draw the triangles like these, and you draw the other triangle like this, so you'd see that this one is A, D, B, this one is A, D, C, and these are equal to each other. So you have therefore that AD equals AD. So you have that. So they are congruent because all the sides are, the corresponding sides are the same. So this is the right hand side, the right angle, hypotenuse, and the side. So you can obviously see that each of the interior angles here is 90 degrees here, 90 degrees there. So you have that, you have this angle is 90 degrees, 90 degrees. So you can look at that as the right angle, hypotenuse, and a side. Next question. Right, in this question here, we're looking at a school field is rectangular in shape. It measures 50 meters long and 30 meters wide. Determine the perimeter of the school field. I'm giving you 2 minutes because it's 2 marks. Please try it. You need to let me know if you want to go to the bathroom. Okay.
Okay.
If you want to go and drink water, please let me know.
No, I'm fine for now.
All right, that's fine. Thanks.
Is the perimeter of the school field 160?
Okay, let's just check that one. Let us check that one. Yes, it is 160. Well done. So to do the perimeter here, you'd have to realize that the perimeter is actually 2 into 50 plus 30. Fifty plus 30. Okay, so what is this? Is 80 by 2, 160. Right, in 2.2, determine the area in square meters of the school field. Right, I'm giving you a minute to find the area and let me know what you think the area is. Okay. I'm giving you a minute to find the area.
Is it 80 meters squared?
Okay, that's fine. So the area, yeah, it's gonna be length by breadth because we're dealing with a rectangle. So the area is length by breadth, which is the area of the rectangle. The longest side is 50 and the shortest one, or this shape is 30 meters wide. So it is 50 meters by 30 meters. What is 50 by 30?
150.
Yeah, it's 1,500. 1,500 square meters. Right, obviously, if a learner runs around the field 5 times, how many meters would he or she run? 1 mark. What do you think? So you have 1 minute to try that one. Let me know what you think.
Is it 800 meters?
So let's look at this one. Obviously, this learner runs around how many times? 5 times. But the perimeter is what? Is 160. So it's going to
160.
be 5 times the perimeter, which is 5 times 160. What is 5 times 160?
Yes.
Is 800. 800 meters. So exactly 800 meters. 800 meters. Next question. If you run around 5 times around a soccer pitch, you are effectively doing what? You are multiplying the perimeter by 5. Okay, let's look at question 3 now. Classify the 3D object by matching its shape in column A with its name in column B. Write your answers like these. 3.1, 0.4D. Right, let's look at 3.1.1. So now you need to match. Classify the 3D by merging. So if you look at 3.1.1, does it match with A, B, or C? And the 3.1.2, let's look at this one here. 3.1.1, what does it match with?
A cylinder.
It is certainly a cylinder. So in other words, 3.1.1. Right. In other words, 3.1.1, the option is B. 3.1.2, what do you call that one?
It's a triangular prism.
Well done. This one is a triangular prism. So in other words, we said this one is a cylinder. This one we've already said is a triangular prism. So it is actually C. 3.1.3. What do we call 3.1.3?
A rectangular prism.
Yes, because that is what obviously is only left, and this is called a rectangular. Rectangular prism. So you're dealing with that one, which is A. Next question. Look at the diagram of a cube and answer the questions. Zero point 2, look at the diagram of a cube and answer the questions. Complete a cube. Okay, complete. A cube has faces, vertices, and edges. So in 3.2.1, what do you think? A cube has what faces?
6 faces.
Well done. So a cube has exactly 6 faces. Because you can count the number of the faces. You have 1, you have 2, you have 3, you have 4, you have 5, you have 6. So there are 6 faces. How many vertices does the cube have? Let's count the vertices. Obviously, the vertices are pretty obvious. How many of them? 1, 2, 3, 4, 5, 6, 7, 8. So these are 8 vertices. How many edges are there? Let me give you the edges to count. Edges are, this is an edge. This is another edge. This is another edge. How many edges are there?
Is it 24? If I'm counting correctly.
Okay, let's count edges at the top. The top thing, like this one, has how many edges? This square at the top. How many edges does it have?
4.
It's 4. The bottom has 4, right? So you have 4 plus 4, that gives you 8. And then you have 1, 2, 3, 4. What is 8 plus 4?
12.
12. 12 edges. Right, in 3.2.2 now, you must be able to determine the total surface area of the cube. What is the total surface area of the cube? I'm giving you 2 minutes. Please try it. Total surface area of the cube. What do you think?
Surface area. Six.
Okay, let's look at it. In 3.2.2, the surface area is 6 times the area six times the area. The area is side squared. So okay, so we're dealing with that one, obviously. Yes, please, my dear. All right, my dear. Right, so you shall have this one here. Right. So you have this here. Okay, so you have this here. Right, so now look at that carefully. Right, so obviously now you need to determine the total surface area of the cube. So anyway, total surface area of the cube is 6 times side squared, because now the each phase, because there are 6 phases. So now 6 faces of this would be each one is side squared, but there are 6 of them. So you have 6 by what? 6 by side squared. Okay, so right. So look at try the next one. Try 3.2.3. Hello, my dear. Right. So what do you think? Determine the volume of the cube. What is the volume of the cube?
Hmm.
What do you think the volume is?
Volume.
Yes.
How much space? did
Yeah,
you
so
say?
the volume is actually side by side by side. Okay, it's side by side by side, right? And then the volume is side cubed. So the square, the surface area is 6 faces times the area of each face, and therefore the area of each face is side squared. So you multiply by 6 for the number of the faces, but the volume here is the side by side by side, so it's side cubed. Next question. Okay, here now we're looking at the figure below. Look at the figure, look at triangle A on the square grid and answer the questions. Reflect the triangle on the square grid over the mirror line and call the new vertex A primed, okay? So let's look at that one. If you call the vertex A primed, now you need to answer the question where that one is gonna be, right? So let's look at that exactly. Where is that gonna be here? Right, so you need to reflect the triangle A on the square grid over the mirror line and call the new triangle. So we're dealing with 4.1. So now, in your view, if you reflect this triangle here, where will the image be?
On the other side of the line, facing the triangle
On the
A.
other side of the line, facing which side?
To the right to triangle A.
Yeah, so you need to count the blocks and say, here you have a block, something like this. Something of that nature. In which case, therefore, that would become the image A primed. Rotate triangle A primed 90 degrees clockwise and label the new image A double primed. So you need to rotate A primed 90 degrees and label the image A double primed. Okay, if you rotate the image A primed 90 degrees clockwise, where is it gonna be?
Would it be back on the other side?
90 degrees clockwise. Obviously, you need to take one corner and rotate it 90 degrees clockwise. Right, so if you rotate it 90 degrees clockwise, maybe you take this, you mark this vertex. And you start rotating it 90 degrees clockwise, then you have to rotate like this because that will be 90 degrees clockwise. Right, so if you rotate it 90 degrees clockwise, or it's going to be rotated in that manner. In which case, therefore, it's going to be pretty much rotated in a way that will displace it, and it's going to be displaced in a way that places it in the okay. All right. So if you rotate it clockwise, then you need to rotate it across. So if you do, you can even put a line here. Then now start rotating it. Okay, if you rotate Let me see. Um, but if you rotate 90 degrees, the other one is going to be like here. Or right, so you can rotate it like that so that it sits that way. And if you do that, it will sort of be on the other side of the line. And right, it will certainly be on the other side of the line. So if you rotate it, for instance, that way, very likely to be on the other side of the line, giving it exactly a thing like that. Something of that sort. Right. So next question. 5.3, translate triangle A um let me see now. Right, translate the triangle A 9 units to the translate triangle A 9 units to the left and 5 units up, and label the image triangle B. Um, right, so if you translate A 9 units to the left and 5 units up and label the image triangle B. Let's move A 9 units to the left. So in other words, you're gonna move A that way. Let's start here. So that's gonna be 1. Okay, so it's gonna be, it must go to the left. So let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so you are doing 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and then now this front of the triangle is going to be obviously 9 units there. Right, so if it would have traveled 9 units, it means that every part of the triangle would have moved 9 units. Every vertex and every part of it would have moved 9 units. But obviously, it moves 9 units, then you have 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5, 6. It's like about here. 1, 2, 3, 4, 5, 6. Okay, that's 1, 2, 3, 4, 5, 6. Okay, so you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you're here. So now you put this one here, like this. Okay, translate the image 9 units and 5 units up and label it image B. Right, so you need to move it 5 units up. Right, so if you move it 5 units up, right, let's count 5 units up. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So placing this vertex there, then goodness me, right, you have something like that. Because this one now is your. So you have something like that. So now you would call this image B, like that. And label the image B for 2 marks. So you'll have something of that sort. Next question. Question 5 is about Mr. Abrahams. Okay. Miss Abrahams recorded her class test results. The test was out of 50 marks. The learner's results are displayed in a stem and leaf diagram. How many learners wrote the test? Okay, let me give you 1 minute.
Is it 96?
Okay, let's check. Let's check. I'm checking. Right, so we're dealing with 5.1.1. How many learners wrote the test? So you'll have to count because these are the marks of the learners. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many learners wrote the test? Because we're counting the marks of the learners. So this is like a mark of the learner because this is like 11%. This is like 13%, something like that, you know?
Oh,
Or rather, because the test was out of 50 marks. So these are the marks. So you can say this is 11 marks. This one is 13 marks out of 50. This is 16 out of 50. This is 9, like 19 out of 50, and so on, you know? And so,
okay.
but now if you look at the marks like that, because now you have the stem of the mark, the stem, this is the stem, and this one is the what? Is the leaf. So you have a student who got 11 out of 50, the student who got 1, 3, 13 out of 50, there's a student whose mark has the stem 1 and the leaf 6, 16, and there's a student who got 1, 9. There's a student who got like 2, 0. The student who got like 2, 1, and so on, you know?
Oh, okay.
Right. So how many learners wrote? We counted up to 21 learners, right? So there are 21 learners who wrote the test. 5.1.2. What was the highest mark? Who got the highest mark in the test? What do you think the highest mark is?
48.
Yeah, surely it's the mark 48. So the highest mark is 48 marks out of 50. Determine the median mark. I'm giving you 1 minute to find the median mark.
I have. mm,
So now we're interested in finding the median mark. What is the median mark?
Median.
Yes. Have you ever heard of the median?
No.
Right. Median means middle. The center mark. So we're looking for the middle mark. So which learner got the middle mark? So the middle mark here is in
The
5.1.3, it's going to be the one in the middle. So who got the mark in the middle? Right. So you need to order or rank these marks. So if there are 21 marks, what does it mean there? It means that you potentially have 10, 10, 10, 10. So you need to count 10 marks there, right, to get the middle one. So there's 1, 2, there's 10. I've wrote the numbers here. So you have 10, all right? And then now there is this one here, which is 11. Then there's another 10 because they're 21 altogether. So if you order them, then you have 11, you have 13, and so on. And then now you have 33, and then you have 48. Okay, so these marks, now they're going to be 10 marks here. And then they're going to be other marks here, which is also 10 marks. So in the end, then you have the centermost mark. But you know, you know, um, so if you look at 5.1.3, then determine the middle mark. So that'll be 33. So it will be 33 because it's in the middle. They have 10 marks and 10 marks, and then this one here is the 11th mark. This one is the 11th mark. Okay. Right. So what is the median mark? The median mark is 33. Determine the mean mark rounded off to 2 decimal places. Which one is the mean mark here? Okay. I'm giving you 2 minutes to find the mean mark. What is the mean mark? Need to determine the mean mark. What is the mean mark here?
Mm,
Have you ever heard of the mean?
no, we actually haven't done this yet.
All right. You are learning it here. Okay. So now the couple of things you need to learn about the mean. So this is how we deal with the mean. The mean, because you're going to be doing it this term. Okay. Right. So
Okay.
the mean is you add all these numbers in the stem and leaf. So you add 11, you add 1, 11, then you add 13, and then you add 16, and then you add 19, and then you add 20, and then you add 21, and then you add 21, and then you add 21, and then you add 24, and then you add 28, and then you add, and then you add the 48. You add all of them. And then divide by the number of the marks, and the marks are 21, are for 21 learners. So you have the mean. So if you add all of them, you get 626. So you have 626 divided by 21. And then now if you divide this, they give 29,81. So if you add all of them now, you get 29,81. So now as a reward, Mrs. Abrahams brought a jar of sweets to school. The jar contains 5 red, 4 green, 10 blue, and 3 yellow sweets. How many sweets are in the jar? Okay. So the min mark is
Mhm.
this min mark is also called the average mark. It's also called the what? It's called the
Okay.
average. Mean is also called the average. So you add everything and divide by the number of the items. So the items are 21, like here, the 21 marks. So you add all the marks and divide by 21, and you get this. Right. So so if you look at 5.2.1, as a reward, Mrs. Abrams brought a jar of sweets to school. The jar contains 5 red, 4 green, 10 blue, and 3 yellow sweets. How many sweets are in the jar? What do you think?
22. 22.
Yeah, well done. So there are 22 sweets in the jar. 22 sweets in the jar. How do you get 22? You add all of them up. Right. Because the jar contains 5 red, 4 green, 10 blue, and 3 yellow. Okay. So obviously you can see that there are 22 sweets because 22 is 5 of the red, 4 of the green, 10 of the blue, and 3 of the yellow. Right, so you have this one here, which is 9, and then you have 19, and then you add 3 to 19, you get 22 of them. So they're essentially 22. Right, what is the probability of choosing a green sweet from the jar? What do you think? What is the probability of choosing a green sweet from the jar? I'm giving you a minute
Oh,
to find the probability of choosing a green sweet.
4/22.
Yes. So at this point, the probability is actually of choosing a green sweet. How many green are there? There are 4 green. So the probability is 4/22. Okay. 4/22 can also be simplified to divide by 2, which is 2 out of 11. So we have 2 out of 11 sweets, and that is the answer. Okay. So we have and the time now. What is the time now? The time now is 16:34. That is the time. It's 16:34. Which is the current time. What time did we start? Lindsay.
14:22.
We started at 14:22. Well done. Thanks for remembering. Okay, great memory. So obviously we're supposed to stop at 16:22, but we're stopping at 16:34. It's okay. We've exceeded by how many minutes? Lindsay?
By 14.
By how many?
Oh, I mean 12.
By 12. Well done. Okay, just testing you. I'm just testing your arithmetic. So just forgive me. We exceeded by exactly 12 minutes, but it's okay. Right. I will then see you next time. Right. So we'll communicate again on WhatsApp and see what we can do. But yeah, I prefer that we meet 2 times a week. So we have used today, Saturday. We can also meet tomorrow afternoon when you are back from church and you are relaxed and you have fully eaten and you're not hungry and you are okay. Okay.
Yeah.
You can also meet tomorrow and do more, because I want to make sure that you do everything. That when you get to school, you know what's happening. You know how to calculate the average, the mean, the mode, everything. Okay.
Okay. Okay.
Right. So thanks, Lintry. I'm going to post a video in the next couple of minutes. And so goodbye for now. We'll talk. You let me know of the time for tomorrow. Okay.
Okay.
Okay. Thanks, Lindsay, and goodbye.
Goodbye.
Mm-hmm.